Hello students, welcome to this lecture on metal forming process. This is the first lecture in this series, and in this lecture we will be seeing the different types of metal forming processes. What is hot and cold forming process, what is recrystallization temperature, and what are the properties that will change during forming process. So I suppose at the end of this lecture you should be able to understand the difference between cold and hot forming process and recrystallization temperature. So as the name indicates here, what is forming process? Forming is a process in which form of one workpiece, one form will change into another form by applying some external force. So that force, how that force is applied, based on that criteria, these processes are of four types. So rolling, forging, extrusion, and drawing. Now based on the temperature of the workpiece on which we are going to do the forming process, so based on the temperature we can define forming process in two different categories. Those are hot forming and cold forming. So in this particular lecture our focus will be on hot forming and cold forming, and on these four different forming processes we will discuss in the coming lectures. So let us see the terminology here. So first one is ingot. So ingot is the first solid form of the steel, as you can see in the first picture. Bloom is the product that we get from the ingot. It is a square in cross section. Remember, it is a square in cross section. Billet is hot rolled form which we get from bloom. It is also again square in cross section, as you can see in the third picture. And slab is the hot rolled ingot or bloom rectangular cross section. So it is in rectangular cross section, whose width is 10 inch or more and thickness is 1.5 inch and more. So if you want to differentiate between plate, sheet and strip, then a slab whose thickness is greater than 5 mm can be known as plate. A slab whose thickness is less than 5 mm and width is greater than 600 mm, that's known as sheet. And a slab whose thickness is less than 5 mm and width is also less than 600 mm, that's known as strip. So you must remember the difference between all these three. These all are in cross section of rectangular shape, but based on these dimensions they are defined, or they have given some different names. So here you can see the pictures. Now in forming process, it's well known that we are going to change the form. So if you're going to change the form, then you must have gone plastic deformation. So plastic deformation is the deformation which is beyond elastic limit, and due to slip or grain fragmentation or movements in the grains or atoms and lattice distortion, we get the plastic deformation. Now here is the term that will differentiate between hot and cold forming process. So it is the recrystallization temperature. My dear, you must remember, this is very important. From exam point of view, what is recrystallization temperature? It is the temperature which differentiate whether the process is hot forming process or cold forming process. So it's the temperature which differentiate whether the process is hot forming or cold forming. तो आपको यहाँ पर ये याद रखना है कि किसी भी पर्टिकुलर प्रोसेस के लिए यदि आप ये कहते हैं कि ये हॉट फॉर्मिंग है या कोल्ड फॉर्मिंग है, देन on what criteria you can say that criteria is recrystallization temperature. मैं यदि आपसे पूछूं कि आयरन को मैं किसी पर्टिकुलर टेम्परेचर पे उसको हीट कर उसको जो है फोर्जिंग कर रहा हूँ, उसको हैमर से मैं बीट कर रहा हूँ, और मैं आपसे यदि पूछूं कि बताइए ये हॉट फॉर्मिंग है या कोल्ड फॉर्मिंग है, so the first very step you have to do is you have to find what is the recrystallization temperature of iron. So यदि आप ये पता कर लेते हैं तो आप बता पाएंगे कि वो जो प्रोसेस है वो हॉट फॉर्मिंग है या कोल्ड फॉर्मिंग है. So see here this very important point, and you must remember this one. This point is this one. So if working above recrystallization temperature, then that's known as hot working process, whereas working below recrystallization temperature is known as cold working process. Now there are some different points, like obviously it involves the new structure, strain-free structures, because during the cold working structure, grain structure of the material will change. So at the recrystallization temperature, or if you heat the cold worked material up to recrystallization temperature, then it will become strain free. So this is another criteria on which we can define the recrystallization temperature. It depends on the, again, cold working, how much our material has gone, and it is about 40% of the melting point temperature of the material. So again, this is, a very important formula that you have to remember. In many exams this has been asked, so you must remember this one. Recrystallization temperature for any material or any metal is zero point 0.4 times of the melting point temperature. It is recrystallization temperature, not the temperature where hot working or hot forming is going to take place. Let's assume that for a particular material melting point is 1500 degrees centigrade. So for that material you can say that the recrystallization temperature is 1500 into 0.4. So that's 600 degrees centigrade. Now if forming is going to take place above 600 degrees centigrade, then that is known as hot forming. It can be 700 or 1000 degrees centigrade or 1300 degrees centigrade. In all cases it will be hot forming. And if the temperature is below 600 degrees centigrade, then that will be termed as cold forming. Now don't consider that the material is too much hot at the, even at a 500 degrees centigrade also, then how we can say that it's not a cold forming. My dear, it's not cold forming because the temperature is below recrystallization temperature. Now you must be, I hope you must be sitting with your pen and copy, because this presentation includes only the important points. There is nothing written in this presentation that's not important from your exam point of view. Now remember this line. Many times in engineering service examinations these questions have been asked. Recrystallization temperature for cadmium and zinc is room temperature, and recrystallization temperature of iron is 450, and for steel it is 1000 degrees centigrade. So these are very important points, and one more point is there that I will show you. This is that one, this one. Recrystallization temperature of lead and tin, that's below room temperature. My dear, you must remember this you can take the screenshot of, now you can take the screenshot. These all points are very much important from exam point of view, you must remember. Now let's come to the point, that's grain growth. So I think we can continue and discuss grain growth, then we will conclude this one, and we'll later on we will continue in the next lecture. So grain growth is simply increasing the size of the grains. So how does it takes place? So let me explain you here. Suppose initially grains are in this form. Now if you hammer this one, that means if you do the forming on this one, then grains will be in this form. Okay, now this is again a question for examination. Grain in cold working gets distorted, but it will be continue, it will not be discontinue. So this grain is continue. See here, It is continue, it is not discontinue like this. Okay, so this is again very important point here. So grain in cold working are continue and elongated. So you can write these are elongated. I cannot write by my fingers in the mobile, but you must remember this one. In cold working, grains are elongated. Now after getting grains in this form, if we increase the temperature, then these grains will start converting into form of grains like this. Then these grains will get together and become a big size grains like this, and that's known as grain growth. Okay, so grain growth follows complete crystallization if we left the material at elevated temperature. Generally the process is recovery, then recrystallization, and then grain growth. But as the second line mentioned, it does not need to be proceed by the recovery and recrystallization. Remember this one, it's not at all necessary. Directly grain growth can take place if we leave the material at elevated temperature. In practical applications, grain growth is not desirable. Incorporation of impurity atoms and insoluble second phase particles are effective in retarding grain growth. So to decrease the grain growth rate, if we have the impurities, where is that here, if we have the impurities, this will decrease the grain growth rate. And again, grain growth is very strongly depend on the temperature. So now let's stop here. In next lecture we will start from strain hardening, and then we will complete this particular topic, that's introduction to the metal forming. So this we will complete in the next lecture. Thank you for being with me. Thanks a lot. Have a good day.